Hey everybody, thanks for coming back. All right, today we're talking about something called combinations. This is really similar to the permutations that we did in the last video, but there is kind of an important difference. So let's take a look at what that is. All right, so what are combinations? They're all the different ways you can arrange a group. Now, in a combination, order doesn't matter. With a permutation, order did matter. All right, so when we were talking about permutations, if you flip a coin, heads first, tails second is a different permutation than tails first, heads second. But when you're talking combinations, they are the same. Heads, tails is the same combination as tails, heads. So order doesn't make a difference anymore. All right, it doesn't matter how you order a combination. One combination is one combination no matter what. So in order to figure out how many combinations you have, using the counting principle like we did with permutations, you are going to divide the largest permutation of your group by the smallest permutation of your group. That may sound confusing. Let's do an example. All right, so here we have our dog, our cat, and our duck. We're going to figure out all the different combinations we can make if we put them into pairs. All right, the grouping when you're talking about combinations is very important here. All right, we're going to see a lot of problems where it's like, put them in pairs, put them in groups of 3 or whatever. So the grouping really makes a difference. So right now we're putting them in pairs, which means in groups of 2. All right, I don't want my calligraphy. Okay, so let's use the counting principle to figure out how many we're going to have. So we figure out our largest permutation first. Now in groups of 2, our largest permutation would be 3 times 2. 3 is the maximum number of options we have times 2. So that's our largest permutation. We're going to divide that by our smallest permutation, which would be 2 times 1. All right. So if we just carry out our multiplication here, we'd have 6 over 2, 6 divided by 2, which is 3. So we can only have 3 different combinations pairing these 3 animals up. All right, so what would they be? Well, one is dog and cat would be the first obvious one. So dog, cat would be one combination. All right, now we could not list cat dog as another combination because that's the same as dog cat. Doesn't matter what order you put them in, it's the same combination. All right, we could have dog duck. All right, and then our last combination would be cat duck. All right, and like I said, order doesn't matter anymore, so dog duck is not another option. We've already listed that. Duck cat is not another option. We've already listed that. All right, so here are all of our combinations. Let's do a few more examples. All right, how many combinations could be made out of pairs of students in this classroom? So I have 11 students in my classroom. If I wanted to put them into pairs, how many different pairs could I make? So I take my largest permutation, which would be 11 times 10. When we're talking pairs, 11 times 10. And then I take my smallest combination, which would be 2 times 1. All right, and then we multiply. 11 times 10 would be 110. 2 times 1 would be 2. 110 divided by 2 would be 55. I have 55 possible pairs I could make out of all the students in my room. Okay, how many combinations could be made out of the numbers 1 through 9 if I put them in groups of 3? Okay, so I begin with my largest permutation, which would be 9 times 8 times 7. Divide that by my smallest permutation, which would be 3 times 2 times 1. All right, so 9 times 8 times 7 would be let's figure that out. 9 times 8 times 7, 504. That's what I thought it was, just for the record. 3 times 2 times 1 would be 6. And then 504 divided by 6 is 84. So there are 84 different combinations of the numbers 1 through 9 if I put them in groups of 3. All right. A few more examples. How many combinations can be made out of the numbers 1, 2, and 3? List them. So notice it doesn't tell us to put this in a smaller group. All right, so we are making combinations out of all of our choices. So my largest permutation here would be 3 times 2 times 1, because we're talking about 3 different things, 3 different numbers. Doesn't matter what the numbers are here, we're talking about 3 of them. All right, and we're going to divide that by my smallest permutation, which just so happens to be the same 3 numbers, because we're not making a smaller group. We're including everything. Okay, so you may already notice we don't even have to really carry out the multiplication here, but we're dividing something by itself. We're dividing this expression by the same exact thing, which is going to give us an answer of 1. All right, a combination of all 3 of these numbers, it doesn't matter what order you put them in, it's going to be the same combination every single time. So honestly, we could say 3, 2, 1. We can make our list. This is our combination. 3, 2, and 1, or 1, 2, and 3, or 2, 1, and 3. It doesn't matter what order, it's all the same combination. There's only one combination because we are including every single option, every choice, every item. All right, so anytime your combination, anytime your options aren't broken down into smaller groups, you're going to end up with one possible combination if you're including everything. All right, how many combinations can be made out of the letters T, U, and V taken 2 at a time? So there we've got a smaller group. So T, U, and V, so we've got 3. So our largest permutation, which is 3 times 2, over our smallest, which is 2 times 1, okay, which is going to end up being 3 different combinations. And what are they? Well, we could do TU, we could do TV, and the last we could do is UV. Those are the only 3 combinations we can make here. All right, how many combinations could be made out of a square, a cat face, a clover, and a radiation symbol if you put them in groups of 3? So groups of 3. So we've got our largest permutation, which is 4 times 3 times 2. And our smallest permutation would be 3 times 2 times 1. So we would have 24 divided by 6, and we would have 4 of them. Okay, so that's it for combinations. Thank you for your time, and I hope that you can use this.